Hello everybody, welcome to Sakshi Gopala chemistry classes. Dear student, we have already dealt with the two sets of MCQs. Now in this video class, I am starting with question number 21, that is from set number 3. So see, what is given in the question? In a Schottky defect. So first of all, let us understand what is Schottky defect. See, to memorize it, S for Schottky, S for similar. When similar number of cations and anions, they are missing from their actual lattice site, it is called a Schottky defect. Now due to their missing, it leads to decrease in the density of the crystal. This much information you must know about Schottky defects. Okay. Now let us see what are the given options. In option number A, it's given N ion moves to interstitial site between the lattice point. This is a wrong one. Now B, electrons, they are trapped in a lattice site. This is also wrong one. Now C, some lattice sites are vacant, right? Because the cations and anions, they are missing. So this is the correct. Now see, let us take the fourth option also. Some extra cations, they are present in the interstitial sites. So this option is also wrong. So in a Schottky defect, correct answer is some lattice sites are vacant. Now we have the next question. See, which type of semiconductor is formed when germanium is doped with gallium? So dear children, germanium belongs to group 14, right? Now it's talking about doping. So doping का मतलब होता है कि definitely there is change in the conductivity. So see the option number 3 is written no change in conductivity. So this option is wrong. It becomes superconductor. This option is wrong. Now see, whenever we know that when we are talking about doping in group 14 member silicon germanium, if we dope it with a member of group 13, then P type of semiconductor are formed. If we dope with a group 15 member where the number of valence electron is 5, then we get a N type of semiconductor. So in this case, gallium comes in group 13. So the correct answer is P type semiconductor. I hope this question is clear to you. Now the next question, it is somehow related with your previous question. So what is answer here? To get an N-type semiconductor, germanium is doped with. So we all know that germanium should be doped with a group 15 member. So as to get an N-type of semiconductor. So let us take the option. See, gallium, arsenic, aluminium and boron. So gallium, aluminium and boron, they all comes in group 13, whereas arsenic is a member of group 15. So what is the correct answer if we want to get N-type semiconductor? So germanium should be doped with a group 15 member. So the correct answer is arsenic, right? Correct answer is arsenic. Now, the next question with us is question number 24. Here we have to choose the false statement. See, whenever such type of questions come, you have to read each and every option very attentively, okay, and try to understand its meaning. See, first one, the conductivity of a metal, it decreases with increase in temperature. See, what you have to mind here, it is talking about the conductivity of metals. Conductivity of metals and non-metals, they both vary with change in temperature, and the variation is different in both the cases. So here it is talking about the conductivity of metal decreases with increase in temperature. Is that so? So let us see. When you increase temperature, right? When you increase temperature, so what happens? Kinetic energy, it also increases. Okay, so with increase of kinetic energy, the velocity of the molecule also increases. Okay, so but what happens? The molecules, the mean free path of the molecule is decreased. Actually, that is decreased, and due to the decrease of the mean free path of molecules, there comes the obstruction on the movement of ion, and hence the conductivity decreases, right? So this option is correct. But dear children, notice that when it will be talking about conductivity of non-metals, then the conductivity of non-metal increases with increase in temperature, right? Now see this second option, the conductivity of semiconductor increases with increase in temperature, right? This is a correct option. Now see, there is no superconductor at room temperature. This is also correct. Now what about the option D? It is written, ionic solid conduct electricity due to the presence of ion. This is a wrong statement. Why this is a wrong statement? Well, reading, it seems to be correct. Ionic solid conduct electricity due to the presence of ions. What is wrong in that? Right? What is wrong in that? You have to think. See, children, ionic solid, they are basically made up of cations and anions, right? And how the ionic bond is formed? The ionic bond is formed due to the complete transfer of electrons, right? There is the presence of a strong electrostatic force of attraction between the ions when they are present in a lattice structure. So we can't say that in ionic compound there is a presence of free ions, right? But when ionic solids, right, they come in molten state, okay, they dissociate into free ions, okay, that free ions able to conduct electricity. So on a whole, when you say ionic solid conduct electricity due to the presence of ions, no, it's absolutely wrong statement. So in such kind of questions, you have to read each and every word with very attention, okay. So the next question is a match type of question. See what is given in the question. See, this is a column A and it is a column B. Here you have to match with each other. Okay. So the very first, देखिए क्या दिया हुआ है. सबसे पहले हम देखते हैं silicon when it is doped with aluminium. Silicon is of group 14 when it is doped with aluminium of a group 13 element, group 13 member. Then we get a P type of semiconductor. So, okay. इसका ये हो जाएगा फोर्थ का ऑप्शन बी, P type of semiconductor. Now children, let us see what about the carbon dioxide. Carbon dioxide, it is a non-polar molecule, we know that. What about carbon dioxide, how it behaves in a solid state? It behaves as a non-polar insulator, okay. Carbon dioxide behaves as a non-polar insulator. Now we have the remaining two options. One is iron in solid state, means any metal in a solid state. Now B option is NaCl in a molten state. So NaCl, it is a salt, okay. Salt is often used as an electrolyte when you are talking about the electrolytic conduction that you are going to read in the future coming chapters, right. So NaCl in a molten state, it behaves like an electrolytic conductor because as a electrolyte we used NaCl. Now what about the iron in a solid state? Or it can give any type of the metal. It can give aluminium in a solid state also. So metal in the solid state behaves like an electronic conductor. This is a question. It is also asked in Jawahar Navodaya Vidyalaya exam this year only. Okay. So you should be very clear कि matching type of question usually from this chapter it is asked. Now children, moving toward the next interesting question. See, it is asked here, pure silicon and germanium behave as, given are the option conductor, insulator, semiconductor and piezoelectric crystal. So, आप क्या इसका आंसर लगाएंगे? If you want to choose answer, आप सभी लोग you are going to take the semiconductor, but that is a wrong answer. See, once again go back to the question and read. What is written here? In the question it is asked about the conductivity of pure silicon and germanium. So, अगर ये pure नहीं होता, then what would be your answer? They behave as a semiconductor, because silicon and germanium, they have given the title intrinsic semiconductors, right? Now, when speaking about pure silicon and germanium, our answer is insulator. Because in pure state there is no conductivity, or there is very little, very poor conductivity order, so it is behaving like an insulator. In pure state, always mind the word pure, right? So now children, here we have a very super hit question which develops the concept of magnetism. Okay, so see, here is also given the matching type of question. Here is the type of the magnetic substances. First one we have the ferromagnetic. A ferromagnetic substance क्या होते हैं? Right? Ferromagnetic substance are those substances which arrange their magnetic moment of the domain in the direction of the magnetic field. Right? They align themselves. They align their domains of the magnetic moment in the direction of the applied magnetic field. So let us check. See, in the option number C, यहाँ पे जितने भी magnetic moment हैं, they are in the same direction, right? In the direction similar to the magnetic field. So when we are talking about ferromagnetic substance वो सब्सटेंस होते हैं जो अपने डोमेन को, अपने मैग्नेटिक मोमेंट को जिस डायरेक्शन में मैग्नेटिक फील्ड अप्लाई कर रहे हैं, उन they align themselves in that same direction. Right children? Now talk about the ferrimagnetic. See, ferrimagnetic substances are those substances which have their domain of magnetic moment in unequal number. So see the option number 1. Here we have 1, 2, 3, 4. The domains which are marked in black color, magnetic moments 1, 2, 3, 4, 5, 6. They have the plus spin. Now the magnetic moments which are marked in pink color, they are having the negative spin. So ferrimagnetic substances are those substances which have unequal magnetic moments. So you can mark it like this. Now children, what about the antiferromagnetic substances? So the antiferromagnetic substances, they cancel out each other magnetic moment. So they don't possess any property of magnetism. See, antiferromagnetic substance here, one of plus spin, another minus spin. Plus spin, minus spin. Here plus spin, minus, plus, minus. So antiferromagnetic substances are those substances which cancel out each other magnetic moment. Now let us talk about dimagnetic substances. They are those in which there is absence of paired electron, or you can say all the electrons, they are paired. So the last option, see here every electrons, they are present in the paired state. Now what about the paramagnetic? Paramagnetic character is the property of the presence of unpaired electron. So option 4, this is unpaired electron, right? I hope children this question is clear to you. Now children, here we have another question, question number 28. It is a theory based question. See what is given, Fe3O4. Fe3O4, what is the name of Fe3O4? It is a magnetite ore, is ferrimagnetic at room temperature. Now, but at 850 Kelvin it becomes, it means that when you are heating this ore, it turns into, okay, dimagnetic, ferromagnetic, paramagnetic and antiferromagnetic. So when you heat this ore, the ferrimagnetic property is being lost and it develops paramagnetism. So it is also usually asked question. Okay, in many exams you find this question. Now children, moving to question number 29, see, the lattice sites in a pure crystal can be occupied by. This question comes from the very first line of the solid state. What you have learned, the constituent particles in the bracket, atoms, molecules, ions. Okay, they occupy the lattice site. Do you ever learned about electrons? No. So the correct answer for this question is electrons. Electrons never occupy the lattice site. They are always present in the interstitial sites, right children? So lattice sites in any pure crystal, they are occupied by their constituent particles, say atoms. It may be ion, it may be a molecule, but it never be an electron, right? So my dear children, here we have the last question of this set, question number 30. See what is asked. The charge acquired by a p-type semiconductor. This is also one of the intellectual questions. See, पूछा है कि p-type semiconductor में क्या charge होगा. It may be positive, negative, neutral, or it is dependent on the concentration of impurity added. So my dear children, in making of a p-type of semiconductor, what you do, you doped silicon or germanium crystal with a group 13 members so as to get a p-type of semiconductor. Now what happens? Any electron, it vacates its original site so as to satisfy the valency, so as to satisfy the lack of valency from the group 13 member, and in this process there creates a electron hole. Okay. Now that electron hole leads to the conduction of electricity, and that leads to the formation of a p-type of semiconductor. But my dear children, is that any kind of charge gained by the p-type of semiconductor? No, absolutely not. So p-type semiconductor is neutral. It has no charge. Okay. I hope the questions which I discussed in today's video class is easily understood by you. Okay, we will see the other set of questions in next series. Thank you all.